Hello everyone. In this video we will talk about cross validation. So what is cross validation? Cross validation is a technique in machine learning to evaluate the performance of a model. It involves partitioning the data into subsets, training the model on some of these subsets, uh, and testing it on the remaining subsets. The process helps ensure that the model generalizes well to unseen data and is not overfitting on the training data. In this lecture, we are going to be doing a five-fold cross validation. So if you remember, we had 4,192 data points. And what we are going to do in cross validation is split these data points into 5 equally spaced subsets, and each would have around 838 data points. I think there would be 2 subsets with 839 data points. And in the first iteration, what we are going to do is we are going to be using the first 4 subsets for training and the last one, the 5th one, for testing. And in the second iteration, we are going to be using first, second, third and fifth as our training set and fourth as our test set. And similarly, in the third iteration, first, second, fourth and fifth as our training and third as test, and so on. So we will have 5 iteration, and at the end we will have 5 scores. For example, we will have 5 R2 score values or train loss root mean square values. So what we are going to do is we are going to be taking the average of all of these, and that would constitute a cross validation score. So coming back to the Google Colab notebook, just to refresh our memories, we are going to be installing RDKit and Pytorch geometric along with various other libraries and modules. So let's go ahead and do that. This is the same random seed that we have been using throughout the series. And in here we are loading the Lipophilicity _ final CSV file, and we are generating our graph data. Let's define our model and optimizer. So in here I'm using the default hyperparameters. I'm not making any changes. Same train and test functions which we have discussed in previous videos. There are not much change. So now in here, this is the code for cross validation. So let's break down this code one by one. Now this if name equal to main, this line checks if the script is being run directly or not imported as a module. And if the condition is true, the following code block will be executed. So it is running directly, so this code would be executed. We are doing 5-fold cross validation, so k folds is 5, and we are training for 75 epochs. This initializes results list. So this list will store the results evaluation metrics from each fold. And in here what we are doing is k fold from sklearn dot model selection. So up here I have imported k fold from sklearn dot model selection. So k fold module is used to create k folds, or in our case 5 folds, with shuffling enabled and a fixed random state for reproducibility. This would just print a separator line for better readability. And in here, so this line of code will iterate over each fold of the cross validation. Train IDs and test IDs are the indices of the training and testing samples for the current fold. So let me just show you what I mean. So we are generating k folds or 5 folds here. Here we are just using 5 folds. So now if you print the fold, that would just print the fold number. So 0, 1, 2, 3 and 4, since we have 5 fold. And the train IDs in here, so if we just iterate once, it would just print the indices of the train IDs. So these are the indices of the train IDs in the first iteration or in the first fold or zeroth fold, whichever you want to say. And if you want to print the length, that should be 4/5 of the total data set. 4192 multiplied by 4 and divided by 5. So 3353 or 3354. So 3353 is the length of the training IDs, and the rest 839 should be the length of the test IDs. So in this way, every time it will iterate through the loop, it will grab the different indices or different folds for testing. So yeah, let's then go ahead. So this is again a separator line, and this would print out the fold number. Here subset random sampler is used to create samplers for training and test data. Data loader is used to create data loaders with a batch of 32. So basically when we are using data loader and we input graph list batch size, along with that we need to put in the sampler. So that sampler would sample the training IDs or test IDs from this graph list. So the train loader with graph list and train sampler would provide us the training data for that particular iteration, and same for the test loader. Here this is again the same code where we need to reset our parameters before the current fold, and this loop trains the model for the specified number of epochs, and every 15 epochs it prints the training and test loss, which is root mean square error. And when the process is complete, it would just print out this statement, and then it would start testing. It would save the model. So this is another way to save this model.state dictionaries and save path, which is just the folder of Google Colab. I'm using f string to distinguish the model names with the fold number, and in the end the results would be appended to the this empty list over here. And what I want is, I want the metric as for training it will show the root mean square error, but eventually I want the metric as R2. That would kind of give you a better understanding of the results. So here in the evaluation function I am returning R2. So at the end of each fold it would print out the R2, and finally the cross validation score would be the average of the R2 score of each fold. So yeah, that was all the code for cross validation. So let's run this. So it has started running. So let's run the code. So it has started running. As you can see, for fold 0, for the 0th epoch we have training loss of 1.2594 and test loss of the 1.1563. so these are root mean square error loss, and it would print out the losses after every 15th epoch. So as you can see here, after 15th epoch training loss has come down to 1.1 and test loss to 1.08. So let it finish, and once it's done I will get back to you. So as you can see, it has finished running the code, and these are the train and test losses for fold 0, and the R2 score for 0 fold is 0.618. Second one it's 0.66, for third 0.41, and for fourth it's 0.53, and for the last one it's 0.59, and the overall 5-fold cross validation R2 score is 0.56. So in this way you can cross validate your results, and these are the saved models for reproducibility. you can load these models and you can reproduce the same R2 score. So yeah, this is it for this video. In the next video we are gonna be training our model again with the tuned parameters and doing some post hoc analysis. Thank you for watching.